Hi everyone, welcome back. In this final example for this week, we're going to talk about something called transformations. And before we get into what the topic is, let's just, as we did in the previous two examples, right? I started with a new sketch over here. I got a randomly generated name, and I'm simply going to rename this sketch with a meaningful name so I can find it later and just make sure I hit the save button so that it's saved onto my account. Okay? All right. And okay. And then the other thing we're going to do, which we're often going to do at the beginning of every sketch, is just expand here the size of our canvas to fit the size available of our preview window. Just a side note here, notice that if you simply just resize like this, it doesn't automatically restart the sketch because I don't have this. Yeah, you have to hit play again, and then the sketch will run, and it will automatically update at that point. Okay, so just a good little reminder thing to point out. Let's also make a black background here, and let's talk about transformations. Now, in the previous lesson, we talked about the coordinate system, and we said in p5.js, 0, 0 is in the top left corner of the screen, and then coordinates go up on the x-axis, right? The numbers go up that way, and then on the y-axis, the numbers go up as we move down on the screen. And this is kind of like the default state of things. Okay, if I go and draw here let's turn off the fill, set a white stroke, just some drawing color parameters and shape parameters, and then we'll draw a rectangle at 0, 0, and we'll make that rectangle, it's not really important. Let's say we'll make it a square for now, 200 by 200, or maybe 300 by 300, just so it looks a bit more rectangular. So by default, 0, 0, right, is the corner of the rectangle, and 0, 0 is this point over here. We saw that we could change the rectangle mode by going center, right? The default is corner. And circles are the opposite. The default is center, and corner is an optional mode. Okay? So my corner is my 0, 0 is now the center of my rectangle. Now let's say I wanted to draw this rectangle somewhere else, right? I could change the coordinate. Maybe I make this 300 and 300, right? So this moves it to 300 on the x-axis, 300 on the y-axis, or I could put it in the center of my window by saying width divided by 2 and height divided by 2. So if I take the width and divide it in half, I get the center. And if I take the height divided in half, I get the center vertically like this. Okay? So my shape now appears in the center of the screen. So nothing new so far. Now, the fact that the origin is in the top left corner over here is actually not something that is immutable, something that is fixed. We can change the location of the origin if we want to by using something called transformations. There are 3 transformation commands available to us in P5. We have translate, which will allow us to move the origin by a certain amount, shift its position. We have rotate, which rotate will take our entire canvas and it will rotate it around the origin point, and we'll demonstrate that. And then the last one is scale. Scale will simply shrink or stretch what we draw by a certain scale factor. So these transformations we can use to manipulate, again, what the behavior of those drawing command looks like. So for example, instead of drawing the rectangle here at width and height, I could draw this rectangle at 0, 0, right? And I could move my origin to be the center of the screen. So we could use translate to do this. So I'm going to go translate, and then we're going to move width over 2 and height over 2. So translate allows us to shift the origin by a certain amount. So now I've translated my origin to the center, and this rectangle is being drawn at 0, 0 because my origin is now over here, right? So it started by default over here, and now we've used translate to move it into the center. So that also now means that we have negative coordinates on the left, right? Now if we want to go to the left, we can go negative. right? We could draw a rectangle. Let's make them, let's make those more like smaller squares, maybe. We could draw a rectangle at minus 150, right? And we could draw also another rectangle if we wanted to at plus 150, or just, we don't put anything, we just make it 150, right? So now that we've moved our origin to the center of the screen, right, we have negative coordinates on the left, and we have negative coordinates above that 0 point because that origin can move around. Okay? This orientation, again, it's kind of the opposite of what you would have learned in like high school geometry, where the 0, 0 was at the bottom. In the world of just computer graphics in general, oftentimes the origin will be in the top left corner. Okay? But we moved it over here, and now that means positive is still to the right, positive is still towards the bottom. So if we go left of the origin, now we have negative numbers. If we go up from the origin, we have negative numbers on the y-axis. Right? So we could demonstrate this by having this other rectangle go up if we wanted to. Okay. So we have one rectangle right over here. Cool. And then if we increase again, we could put like mouse X. We could move from here, right? We can go like move from here. And now this is basically offset, right? Even though my mouse is over here, the rectangle is moving by the same amount because we're using the value of mouse X as our coordinate. But the origin, right, is zero. The 0, 0 point has been translated to the center. Right? So we're always using that 0, 0 point as the reference. All right. So that's translate. Okay. The other thing that's worth pointing out with translate that's important if you're going to play with this is that translates are cumulatives, which means once you've moved the origin by a certain amount, if you move it again, let's say I move it by mouse X and 0 over here, these add up, right? So if you move it again, this has the same effect as changing the coordinate over here. This does not make the origin mouse X and 0, right? It did not make the origin up here. It changes the origin based on where it's located currently. So because the default was the top left corner, I translated over here to width over 2 and height over 2. If I translate again, it's going to add to the current position of the origin. So these translates are cumulative. Okay, so all transformations work like that, by the way. They're cumulatives, so they build upon whatever state is the canvas is currently in. Okay. And we'll demonstrate that idea a little bit later on when we start to stack transformations to achieve a specific effect. They do get reset at the beginning of draw. So every frame at the beginning of draw, you have a blank slate when it comes to your coordinate system transformations. So the origin always goes back to the top left corner at the beginning of draw. Okay, so that's translate. Kind of self-explanatory, allows us to move the origin around and place it somewhere it's convenient. And we saw, again, for example, maybe like you're doing a drawing here and you want to create some symmetry, right? It might be convenient to put the origin in the center and then rely on, you draw a shape using a negative coordinate, you draw the same shape using a positive coordinate. So you can move the origin wherever it's convenient for what you're trying to achieve. Okay? It just allows you to position that 0, 0 point and then make everything relative to it from that point on. The other transformation that's going to be commonly used is rotate. Okay? Now, rotate allows us to rotate the canvas, and there's two caveats to rotate. The first caveat is that it will rotate by default. The angle value that we're going to put in here is an angle in radians. Okay? So radians is a unit of angles. There's two options in P5. There's radians and then there's degrees. Most of you are probably familiar with degrees when you think of angles. So like 90 degrees or 180 degrees or 360 degrees being a full circle. Radians are the same. They're just a different unit. And they are relative to the number pi, right? The number pi in math. So if we're working in radians and P5, we could say pi is 100 and is equivalent to 180 degrees. So if we wanted to do like a rotation of, let's say 45 degrees, we could divide pi by 4. Okay, so this is an angle in radians. And we now rotated our canvas by 45 degrees. So we first translated the 0, 0 point over here. then we rotate it, and that's the second caveat, is that rotation always takes place around the origin, right? So wherever the origin is, this is the center of our rotation. So in this case, my shape is drawn as the origin as its center, right? So it's rotating around the origin. Let's say we didn't do the rectangle mode center, right? Here's what would happen. It would now rotate around its corner, right? So we can see it over here. If I comment it out, right, it's rotated around the corner. We're going to animate that in a second, but it'll become a bit easier to see. So first caveat, angles are in degrees. Second are in radians. Second caveat, it rotates around the origin. We'll explain that more in a sec. So for most people, though, working with multiples and fractions of the number pi can be kind of annoying. So we can change that at the beginning of our program here in setup. We're going to use a function called angle mode, and we're going to say degrees instead. So the default is radians, but we're going to switch our angle mode to degrees. So if we do this, now we're able to specify angles using degrees in our program. So we could say 45 here instead of pi divided by 4. Remember, pi is like 3.1416, etc., etc. So we can achieve the similar result here, and we can now work with degrees, which are a little bit easier to work with for most of us. Now, to really illustrate rotation, we can add a little bit of animation to our program. Now, without going too much in depth into variables, we're going to focus on that next week. We're going to use another pre-built variable we have access to in P5. In addition to mouse X, mouse Y, width, and height, we have another variable called frameCount, which is a variable I like to use a lot when I want to just quickly add some kind of changing quantity to the program, and I'm lazy and I don't want to just set anything else up. Frame count is simply a number that starts at 0 when you hit play, and for every frame that the program draws, that number goes up by 1 automatically. So instead of 45, we could imagine putting frame count in here. Note the capital C here in the middle. Remember from the previous lesson, uppercase, lowercase, very critical. These are completely different symbols to p5.js, so we got to make sure we follow the proper capitalization. Sometimes it'll be written like this. Sometimes it'll be all caps, depending on what the reference calls for. Okay. So if I put in frame count, this is actually rotating by a number that just keeps increasing, keeps going up. So that's an easy way to throw some animation in there. Notice that eventually, of course, I'm going to draw more than 360 frames, but because rotations are continuous, like it doesn't matter if that number goes up to 27,000, it's still going to create loops around the circle. Okay, so that's an easy way to add some animation. And let's make the circle bigger here, just for the rectangle bigger, just for fun. And now this is animated. We'll be able to see a little bit better what I mean by rotates around the origin. Okay, if we comment out rectangle mode center and hit play again, you see that the corner, right? This is the corner mode for the rectangle. The 0, 0 is over here. This is what the shape rotates around. So wherever 0, 0 happens to be, this is what the shape will rotate around. Okay? So this is important because you can play with this. Excuse me. You can play with this and you can use different transformations in different order. For example, let's say I'm going to move the origin over here, but then I want this square to actually rotate around the center, but be a little bit away from it, right? So we could move the origin to the center of the screen, right? Then we could rotate. Then we could translate away from that center. Okay, so let's see what that looks like. We're going to translate, and let's use mouse X here so we could play with it and make it more interactive. So I'm going to first do a translate, then I'm going to do a rotate, then I'm going to do another translation, then I'm going to draw my rectangle. So now this looks something like this, right? So I can move away. So my mouse cursor now basically becomes like a slider I can play with to change the value. So now if you add another translate after you rotate, you can essentially rotate around a point, right? You're just moving away from that center of rotation, which is 0, 0. So that allows us to do this. Pretty slick. Right. Now, again, just like with the fill and the stroke, translate and rotate, they affect the entire canvas, right? So anything we draw after that, our canvas is now being rotated and the origin has been translated. So our coordinates, right, have meaning inside this rotated space. Everything else we draw there is also going to be rotated. So there are times when we're going to want to be able to draw only a certain portion of our image using the transformations, using the translate and the rotate, and then do another portion of our program, right, to have maybe a different set of transformations applied to it. For example, maybe I want to be able to draw another rectangle, a smaller one, okay, another smaller one, and I would like that one to just stay in the center, right, and spin around its own center. So one way I could do this, of course, is I could change where I'm drawing it. So I could say, remember the order matters, right? So I could say, okay, let's put it before this translate, right? Put it before the translate. So now this rectangle gets drawn, right? The origin is put in the middle. We rotate the canvas. I draw the first rectangle, then I translate away from there, draw the second rectangle. Okay, so we could do it like this. Now, let's say I wanted this middle rectangle, though, to have a different speed of rotation, perhaps, right? I want to have a little bit more control over how these transformations are applied. This is where we're going to also learn about two commands called push and pop. Okay? So push and pop allow us to um, to create sort of a to save the state of the canvas, right? So let's say I go, we're going to translate the origin to the center, right? Then we're going to say push. And then push is like, think of it as like a save. It says, okay, whatever the canvas is right now, right, whatever transformations were applied, save that state. Okay? Then we're going to rotate, let's say frame count, and we'll make that one go faster. We're going to multiply by 2. A star in P5 means multiplication. So we can't just do an X, we'll do a star. So / means division, star means multiply. So I'm going to multiply frame count by 2. I want this inner circle to spin really fast. Okay. Then I'm going to pop. So pop is going to load the last canvas saved by push. Okay? And then I'm going to rotate by frame count. Oops. Do my translate, do my second rectangle. So when you're working with transformations, push and pop can be pretty useful. You can use them because the transformations stack with each other, right? It essentially allows you to create like a little buffer, a little area where, you know, what happens between push and pop stays between push and pop. Okay, so it allows you to create transformations in there that will only affect this section of the code and not the code afterwards. I could also put the second one inside a push and pop, but then, and you don't need to do the indentation. I do it because I think visually it shows it a little bit better. But in this case, I didn't need to do it for the second one because remember at the beginning of draw, when we come back, for the next round, the canvas transformations are always reset back to the default state. So the origin goes back to the corner and everything else is erased. Okay? So that could be that's a helpful tool here, push and pop. You always want to use them together, right? So it doesn't make sense to push and never pop again. If you do that, you'll realize you can try it out. You'll run into some errors. So these are always meant to be used as a pair, and they allow you to isolate transformations from other transformations in your program so that you could move the origin in a specific spot, maybe rotate the canvas just where you want it, draw something, and then just automatically restore things the way things were without having to essentially do the inverse transformations that you just applied. So it's much easier. Finally, the last transformation that we haven't talked about is scale. The reason I saved that one for last is because we don't really use it as much as translate and rotate. Scale, as the name implies, means that whatever you draw is going to either be expanded or shrunk based on the scale factor. So, and that always applies based on where the origin is. So let's do a quick little demonstration. For example, in the second rectangle, let's say I scale by 3. This rectangle is now 200 by 200, right? And then the first one, Actually, I just noticed the first one doesn't have its rectangle mode center applied to it, so I'm going to move that to the top. Remember, the order matters. Didn't notice it as much at first. Okay, so my second rectangle is now twice as big as what I've specified here. And notice even the outline gets thicker, so it's literally just scaling up the shape bigger. If you want to make things smaller, you can use decimal point. So anything less than 1 will make things appear smaller. So scale can be fun to play with. You can create some cool little effects with scale, but generally speaking, it's not as useful. If you go negative scale, it will reverse things around the origin as well. So you can use it to mirror things using negative scale. We'll get to that maybe in a few weeks when it makes sense, but scale, not as useful as the other two. But still good to know what it does. And you can also scale independently from X and Y axes by putting in different values, right? So I could stretch things out by putting in, say, a scale of 1 on the X axis, but a scale of 3 on the Y axis. So those can be independent as well. And finally, just like rotate, scale is relative to where the origin is located. So let's say, for example, I put a scale here using mouse Y. Now, mouse Y, this is a number that's going to go up. I'm already using mouse X to translate this way. Okay, so mouse Y, I'm going to use it also kind of like as a slider, just for another direction. Remember, that number will go up real fast. Okay, so I'm going to divide it by a lot, just so it doesn't get too crazy. We'll divide it by 100, so it's not as intense. And this is what will happen, right? So this is when it's at 0, it disappears. As soon as we hit 1, we start to be the correct proportions, right? And we're scaling based on where the origin is located. So if we've translated away, right, from, if we've translated away, that we're scaling based on where the origin is. So let's say we were to scale before we translate. Then it would look more like this, right? So we're scaling based on where the 0 point is located. And as we translate the origin, you can see that the scaling is happening relative to the 0 point. So it's expanding, it's expanding away from the 0 point. Sorry about that, just hit the mic. Okay, so translate, rotate, and scale, with scale being the one we're going to use the least, but translate and rotate can be very helpful to create some interesting designs, interesting patterns. Just keep in mind, once you've translated and rotated things, it can become very difficult to know what these coordinates actually are anymore, because now the canvas has been moved around, and that becomes important down the road when we're going to want to do some interactions with the mouse, for example. If you're trying to click on an item that's been translated and rotated, you won't be able to know where that item is on the screen anymore. That's going to matter more for later on in a few weeks when we build games and things like this. But for now, they're a useful tool to create interesting visual compositions. And feel free to use those tools in your first code exercise. All right. Okay. So again, thanks everybody for watching. After that, I'm going to ask you to practice this week by working on your first code exercise. The details for it are available on D2L, but just in a nutshell, this week is all about getting to grips, coming to grips with the syntax, getting familiar with the editor and learning the basic drawing commands. So we're going to write a program that's going to create a drawing. It's going to be a representational drawing, which means a drawing that looks like something. So no abstract drawings this week. We're going to do that in future weeks. So, house, a car, right? These are representational drawings of objects, a tree, something that exists. And my only design criteria challenge is that your drawings should either be cute or evil. I'm going to let you choose which style you're going to go with. And yeah, so you're going to use the different basic drawing primitives that are available to you. This will allow you to get familiar with the coordinate system, working with dimensions and pixels, working with colors, and then you can sprinkle some translates or rotates in there as needed if that makes your life easier. Okay. So have some fun with it, be creative, and I will see you in next week's series of videos. Take care.